Hey guys, and welcome. Today we're going to talk about minerals, right, which is part of the rocks and mineral unit. All right, so just looking upon this picture here, you'll notice that minerals definitely have a lot of variables to them. Obviously, we're not going to be looking at every single mineral because there's so many in existence. But we're going to learn about the characteristics of them. We're going to learn how to identify them a little bit in this course. All right, so first off, the solid part of the earth is made up of rocks. And these rocks obviously are composed of minerals. Okay, so minerals are the simpler forms of rocks, basically, or simpler particles that make up rocks. There's around 4,000 different minerals in existence. They're defined as naturally occurring inorganic solids that basically have their own specific chemical compositions and their own crystalline structures. They are interlocking crystals that come together, and you'll notice their appearances are very different. So they're very easy to mix up. Because 4,000 different minerals is only so many different colors that combinations that you can have, and also there are varying colors also, which we'll talk about in a moment. Minerals are made up of elements, and again, elements, you know, the periodic table of elements, so mixtures of them. Some of them are going to have multiple minerals and elements in them. Some of them are going to be made of one element. So elements are the chemical building blocks of substances. There's only one kind of atom in an element, and that repeats over and over again to make up those elements. There's 92 elements in nature. Others have been produced artificially, so obviously we're going to be looking at the ones found in nature. There's an atomic number, and that's the number of protons in the nucleus and electrons outside the nucleus in the neutral atoms. And here's an example of one, just looking at a block from the periodic table. So they each have a name. They have a chemical symbol, which is either going to be one capital letter or a capital and a lowercase. And they are numbered by the atomic number. And the atomic mass also is another important characteristic of a element, and that's the number of protons added to the number of neutrons, and then a little bit of electrons, because electrons weigh so little in terms of the elements. Okay, so some minerals are made up of one element. So an example of that would be like sulfur, which is only S, gold, which is Au, graphite, which is C, and carbon, and diamond, which is also made of carbon. So diamond actually and the graphite in your pencil are actually made of the same material. However, they were formed in very different ways. Graphite was more on the surface of the earth, whereas diamond was formed deep underground under extreme heat and pressure conditions, and therefore that's why diamond is one of the hardest substances known to man, because of that intense heat and pressure it forms that crystalline structure that's very hard together. So we'll talk about that characteristic in a moment. Most minerals are made up of compounds, which is combinations of elements. So an example could be like quartz, which is SiO2, or halite, which is NaCl. So you can ask the parents. Halite actually is table salt, sodium chloride. So you could ask them, pass the halite tonight, all right, and see if they react to you. And if they don't know that, ask them, pass the sodium chloride, see if they know that one. They're bound to know maybe one of them. If not, you can teach them something new. All right, so just to remind you, the reference table, the crust, all right, which made up of rocks, are mostly made up of silicon and oxygen. Okay, so even by mass and by volume. So the mineral structure of most rocks is mostly going to be made of oxygen and silicon. So the most abundant group of minerals is called the silicates, which contain oxygen and silicon. And they make what's called a chemical structure called a tetrahedron, and these tetrahedrons are repeating crystalline patterns which make up your minerals. So here's an example of a tetrahedron, which looks like a pyramid structure again. These interlock. So here's what they look in atom form. Oxygen atoms are much bigger than the silicon atom, and the silicon atom's in the middle of it. And again, that's what makes that structure you see. So 4 oxygen atoms at the corners, around 1 silicon atom in the center. And again, these start getting rearranged differently when other elements come present, and this is what makes your structures of your minerals much different from mineral to mineral. So different silicate minerals bond or share the oxygen atoms in different ways, and then you get different minerals that are completely different in characteristic. All right, so going through, basically the most important part of the minerals is the properties. Okay, so minerals have physical and chemical characteristics that make them identifiable. Elements in a mineral tell how they're arranged and tell their properties. So first off, crystal form. We're not going to go too deeply into this, but how strongly bonded and how the elements are arranged determines the shape of the individual mineral and can determine a lot about it. So we call this crystal form, crystal shape. Also, sometimes they call it the internal arrangement of the atoms. You may see that in some of the questions. Okay, so 2 silicate minerals, mica, which forms in thin sheets, all right, very flat. Quartz, which is a 6-sided crystal, very hard crystal actually. Again, this will determine a lot about the mineral structure. There are different crystal forms and different habits you can learn about. If you go a little more into minerals, this could be an important part of identification. But we're not going to go that deep with this. Okay, cleavage on the other hand, these are breakage patterns, so minerals have a tendency to cleave or split smoothly if they have weak bonds in the material. The reverse of that is called fracture. Fracture is if there are no weak bonds and basically the crystal fracture or breaks apart unevenly and has an uneven breakage pattern. Cleavage, so is flat parallel sides, whereas fracture is jagged sides, right? Uneven breakage. So example, mica has cleavage because that's that flat sheet one I showed you here. This is the black form of it, which is called biotype mica. There's another one called muscovite mica, which is a lighter color version of it. And then you have halite, which has cleavage. You can see it looks like a cube. This is like a really perfect one. Some of them can be more repeating cube pattern that you'll see up close when you look at it. Quartz is a fracture, and again, even though it has crystals that are interlocking, they are very uneven in size and shape and everything else. Cleavage, so this is the different types of cleavage. Flat sheets is going to be like a one plane cleavage. That's one direction of breakage. A more blocky cleavage or cubic is a 3-dimensional form of it. There are also more of a 2-dimensional forms, but we're not going to, they'll be talked about in the questions. We'll see it on the chart. But usually one plane, 3 planes, we look at the cubic, the blocky structures. And then there are more complex ones. Is a rhombohedral, which is actually 3-dimensional also, which is like a tilted cube. We'll definitely look at that one. Prismatic, we won't really look at the prismatic or the tetrahedron ones as much. They're a lot more complex, and it's harder to read the amount of planes on those. Fracture is anything else. It's uneven, and you can see that in that picture. Okay, the next characteristic I want to talk about is color. Color is determined by the elements present. Color alone should not be used for identifying minerals, so we'll talk about why that is. So number one mineral may be coming in different varieties of colors. So an example of that, quartz, comes in many varieties of colors, so you can't use that alone. So quartz is white, green, red, so purple. So there's a whole bunch of different colors of quartz which will mix you up. Also, many minerals may be the same color. All right, 4,000 minerals is bound to be repeat colors. So these are complications that can really throw you off. So quartz, milky quartz, calcite, halite are all white in color. So it can be mixed up, all right, if you don't know the other characteristics. And that's what we're going to be focusing on moving forward here. So different colors of quartz, as I mentioned, green, bluish, and then a rose quartz is more pink. And then you have 3 white minerals here, quartz, halite, and calcite. Again, so we have to look at them a little further to tell them apart. Okay, so another characteristic that's very important is called hardness. This is a mineral's resistance to being scratched. So Mohs scale hardness is what we've developed to actually compare minerals. It's a list of minerals and their known hardnesses. The 2 that come to mind right away are the lowest and highest on the scale. So 1 is the softest, which is talc. So talc is what you guys know as baby powder. So when they take the mineral and grind it up, you have baby powder. So very soft. You can actually break it with your fingernail when you scratch it. And then diamond, on the other hand, diamonds are forever. They say that for a reason, because diamonds are the hardest substance on Earth. There are some other harder materials we found in meteorites, slightly harder than diamond, but we don't have very many of those. But the ones found on Earth that are the most common in terms of hardness are diamonds. Hardness test determines whether a material is harder or softer. So you take the material, scratch the material, and if it scratches it, it's harder than that substance. So diamond can scratch itself and other minerals that are lower on a chart, which is pretty much everything. Anything that does not scratch, that would mean it's softer. And most of the time the mineral will actually break down in the other mineral when it's softer. Like talc definitely will break on pretty much every other mineral when you try to scratch it. Okay, so also some other things that are commonly used in questions. Fingernail is a hardness at 2.5. Copper penny is 3.5. Iron nail is 4.5. Glass plate, that's the most common one we use. We use that in our lab. So that's a hardness of 5.5. So if we run the mineral on a glass plate and scratch it, that means the mineral is 5.5 or greater than 5.5. If it doesn't scratch the glass, that means its hardness is less than 5.5. Okay, and then we can use our fingernail next. So if it scratches with our fingernail, then it's going to be less than 2.5. If it doesn't, then it would be between 2.5 and 5.5. So we can get that range from that little test. But if you have the other things around, you can get a more accurate measure ahead of that. All right, streak, that's the color of the powder of the mineral. So what we use is a white porcelain tile plate. So we scratch the mineral on the white porcelain plate and record the color that we see. So this is a more true color. It's better than the color of the mineral because it's unique. So you could have a green mineral that shows a green streak, and then you could have another green mineral that actually has a white streak. So it's an identifying property that we can use to help us in our identification. And again, in conjunction with all the other tests, we can get a more concrete answer. All right, so next test is called luster. That's the way the mineral's surface reflects the light. What we're going to look at is whether or not the mineral is metallic. That means it looks like silver or gold, has that shine on it like a metal. So it looks like a piece of metal. So galena is silver, pyrite is gold. Pyrite is also known as fool's gold. And then non-metallic are minerals that look glassy, dull, pearly, earthy. So they can appear shiny, so be careful. Some of those. But they do not appear to look like a metal at all. Okay, so quartz is glassy because it's got that like crystalline look. Talc is dull. Muscovite mica is a pearly look. It's kind of shiny looking, but again, is not metallic. All right, and then lastly, getting down to the last two tests, specific gravity. That's the comparison to the mineral's density to the density of water, which we know is 1 gram per centimeter cubed. So the higher the specific gravity, the higher the density of the mineral. Okay, so that's one test. And the other tests are taking like a dilute acid and dropping it on the mineral and seeing if it bubbles. If it bubbles, then we know that it's either going to be calcite or dolomite. Calcite bubbles immediately when it touches the acid, whereas dolomite would have to be ground up into a powder. You could read that on the reference table. We're going to see that in a few minutes. Magnetite is a magnetic property, and that's basically also known as lodestone. And you can see there things with iron, nickel, and cobalt will actually attract to a magnet, so it will attract to magnetite also. And you can just take another magnet and push it up to magnetite and see if it sticks. That's the way you can test it. All right, so that's it for minerals, and I thank you guys for tuning in today. And again, we'll talk about the chart in a few minutes.